Okay. Now going on to part 2, this gnarly problem. I've duplicated the graph here so it's a little easier for us. So here we're going to start over and imagine that we're using core-based trees. We're going to say that A is the core for the group, for group 1 specifically. So A is our core. I'm going to really color it in here. This is our core. So for group 1. So if C wants to join the group, it joins the group by sending a join message to the core. So C wants to join the group, so it'll send a direct message. I'm going to do this group in pink now. And every point along the way, each router knows that it's now part of the group. F to D. And it also knows which of its links are part of the group. And of course, the core itself is part of the group. So this is the shortest path. 1, 2, 3, 4, 5, 6. So the request goes through C, F, D, E, and A. Now D wants to join. So this we're going to do in dark green. D wants to join. It also sends a request to A, but as soon as it gets to its first top router, D is already on the tree, so the message stops there. So great. It actually just goes to D and doesn't go up to anyone else. B also wants to join group 1. How long, so the typo here, how long does it take to reach all members? Excuse me, so B sends a message to group 1 now. How long does it take to reach all members? So if B wants to send a message, it's not on the tree, and so for core-based trees, the way that a non-member sends a message is you take the message, you encapsulate it in a special header, and you send it to the core. And when the core gets the message, it sends it out to everyone. So in purple, B would encapsulate the packet. So take 1 second here, then 2 seconds here, or whatever unit of time is. Then another 2 here, so that's 3, so 4 to get to the core. And from the core, we now flood the packet on the tree that we have built. So 4 seconds to get to the core, then 5, 6, 7, 8, 9, 10. So 10 seconds to reach all members. Okay, now C wants to send a message to group 1. And since C is a member, it can just flood on the tree that's part of the group. So it sends, and every router along the way just floods using the links that are part of the tree. So 1, 2, 3, 4, 5, 6. And of course it gets sent over here. But to reach all members, it takes 6 seconds. Okay, so now in part 4, question 4 here, C sends a message to group 1. How long does it take to reach all the members? This is a bit of a trick question, as we'll see. So since C is on the tree, it can just send the packet and every router along the way will flood to all other links that are on this tree. So C sends, it takes 1 unit of time, 2 units of time, 3 units of time. And now D will flood this way and this way. E sends this way and A sends this way. So technically it takes 1, 2, 3, 4, 5, 6 seconds to reach the core. But the core doesn't actually count as a member of the tree. So it takes us 1, 2, 3, 4, 5 seconds to reach D. So 5 seconds, because D is the only other member, right? A is just the core. Okay, the link between A and A goes down, so this link goes out. But no other changes in the control plane state occur. Who can still send and receive messages to and from group 1, if anyone? Well, anyone who's a member of the group can still send, right? Because to send, they just give it to their first hop router, who then broadcasts it, or who then floods it on all of the links that are part of this tree. It's only non-members who need to reach the core before that packet can be flooded along the links. So any members can still send, because all the state is in the routers along the way and saved for which links are part of the tree. And that's it. That is DVMRP and core-based trees.